Hello, this is Elizabeth Pluswick. Today we're going to compute effective interest, converting the present value of an investment to a future value using both the formula and the interest tables for effective interest rate, compounding interest more frequently than once per year. So let's look at an example. Then we'll use the equation and the interest table. Say we have an opportunity to invest money at the bank to purchase a CD, certificate of deposit at the bank, and for a term of 5 years. The bank tells us that this investment will earn an annual interest rate of 6%, and it will be compounded quarterly. That means every 3 months or 4 times per year. So N is 4 times per year. There are 4 interest periods per year. The investment will earn 6% per year. What we need to do is to turn this annual interest rate, which we designate by the letter R, turn it into an I, an effective interest rate per interest period. Okay, so let's see how we do that. Say we have $1,000 to invest in this example. So effective interest rate per interest period, I, equals annual stated rate, R, divided by the number of interest periods per year. So 6% is the annual interest rate divided by 4 compounding periods per year, or an effective interest rate of 1.5% per interest period. And remember, there are 4 per year because interest is compounded quarterly. This is a 5-year investment, so we'll actually be earning 1.5% interest rate for 20 quarters, 5 years times 4 quarters per year. So our N, interest periods for the whole investment project, is 20. N is 4 for 1 year times 5 years, so overall, for this whole investment, our N is 20 interest periods with an effective interest rate I of 1.5%. All right, remember we're investing $1,000 and the question is, what is the future value of this investment? What will the value be at the end of the 5-year period? We have a couple different ways to figure this out. If you're comfortable with the calculator, you can start with the calculator, but I think you will shortly move to using the tables that figure out a lot of this for you. So the question is, what is the future value of this investment? 5 years, compounded quarterly, so our N is 20. Effective interest rate per period is 1.5%. Our present value is $1,000. That's the initial amount of the investment. And we're looking for the future value of that investment after 5 years. All right, the formula way that you might want to start with, there's an equation to convert from present value to future value. Take the present value amount times 1 plus I, the effective interest rate, to N, the number of interest compounding periods, raised to that factor, that exponent. So we have $1,000 times 1 plus 0.05 raised to the power of 20. Do that on my calculator, I get a future value of $1,346.86 at the end of 5 years. That's what will be in the investment. We started with 1,000p present value. The future value is $1,346. All right, that's fine. You can do that with a calculator. But I'm going to show you another way to use the interest tables provided by the NCEES. This is the FE Reference Handbook, and you can download this. You should have downloaded this as a PDF. I'm going to turn to the section on engineering economics. In the printed manual, this starts on page 117, or I'm on page 117. It starts on page 114 in the printed book. In the PDF, the page numbering is slightly different, but it's close, like page 120 or something in the PDF file. Anyway, you're looking for the engineering economics section. And what we're going to do today is go over to the table, the interest table factors. And in our example here, we computed an effective interest rate per compounding period of 1.5%. Remember, the bank said the annual interest rate was 6%, but we converted that interest rate to a quarterly amount per interest period each quarter. Our effective interest rate is 1.5%. So that's the table that we want to be using. And we are trying to find future value. So we want to find F, find future value, given, the slash indicates the word given, P, the present value. We're given the present value and we want to find the future value. So we go to this column on that particular interest factor table, 1.5%. The N over here is the number of interest periods in the entire project. So we said N was equal to 20, 5 years, times 4 quarters per year, so N is 20, and we come over to the column find F given P. So the factor that we're going to want to pull off this table is 1.3469. Lined up with the N equals 20 and the interest rate 1.5%, the column is the find F given P. 1.3469 is the factor that we want to pull. And that factor then is multiplied, and here I've given you F times F, find F given P column, N equals 20 row, so the factor is 1.3469. And you multiply that factor times what you're given. We were given P. We want to find F given P. So find F given P, $1,000 initial investment, and that factor we identified as 1.3469. Multiply that by the present value, and you will get the future value of that investment, $1,346.90, which is very similar to just a few cents rounding difference that we got using the full equation. So you can see that the equation method and the table method give basically the same answer. That is the future value of this investment at the end of 5 years using a 6% annual interest rate compounded quarterly. In 5 years, the balance will be $1,346.90. And that's how to use the interest factor tables and the engineering functional notation for finding something given the rest of the factors. Next video, we'll do some more examples using these interest tables.